We're going to continue our work from yesterday in describing data distributions using mean and mean absolute deviation. Our objectives today are that we can calculate the mean and mean absolute deviation for a data distribution, and that we can use the mean and MAD to describe a data distribution in terms of center and variability. In Lesson 9, we learned about a mean absolute deviation, or MAD, as a method of measuring variability, giving us another strategy to describe a data distribution. There are several ways to describe the data distribution. The mean number of pets for these students is 3, which is a measure of center. There is variability in the number of pets the students have, and data values differ from the mean by about 2.2 pets on average, or the MAD. The shape of the distribution is heavy on the left, and then it thins out to the right. In other words, we've learned how to describe distributions based on their shape, center, and spread. Take a moment to collect a piece of paper and a pencil. We're going to work through part 1 of the independent practice work for Lesson 10. Copy this table on your paper. This shows the weights of 7 different students' backpacks. We need to complete the table by recording the deviation and absolute deviation. When looking at the deviation versus absolute deviation, there's one key distinction we need to make. When we talk about deviation, we're looking for the distance of a value from the mean and the direction. 2 to the left of the mean would be an example of deviation. When we talk about absolute deviation, we're talking about the distance from the mean only, regardless of direction. Think of this like the absolute value of a number, which measures its distance from 0 without taking into account if the number is in the positive or negative direction. To find the deviation, we first must know the mean of our data set. We find the mean by adding all of the data values and dividing them by the total number of data points. In this case, we add 18 7 times, then divide the sum by 7. Because each of these values we're adding is 18, our mean will also be 18. Because each of our values in the table also equal 18, none of the values will have a deviation from the mean, so we record this as 0. Notice that we don't have to list a direction because each of these weights lies exactly on the mean. We can represent this using a simple dot plot like the one here. When looking at the absolute deviation, we're simply recording the deviation without direction. Since each of the deviations is at 0, our absolute deviations are as well. Our next task is to describe the distribution based on its center, spread, and shape. The center can be measured by the mean of 18. There is no variability, meaning our spread is all concentrated on a single value, and there is no skew in shape. Suppose that Alicia's backpack weighed 17 pounds instead of 18 pounds. We should be able to come to some general conclusions without making any formal calculations. For example, how would the mean be impacted by one of the backpacks having a lighter weight? We should be able to determine that the mean will be smaller because the data has shifted to lesser amounts. We can also conclude that the mean absolute deviation will increase because earlier the MAD was 0 since there was no deviation. Now there is a very slight deviation. Suppose that Alicia's backpack weighed 17 pounds instead of 18 pounds, and Fred's backpack weighed 19 pounds instead of 18 pounds. How does this impact the center, spread, and shape? The mean would return to 18 because the deviation of 17 and 18 are both 1, but in opposite directions. There's more variability because there are now 2 different values besides 18, so our mean absolute deviation would increase from both our original mean absolute deviation, which was 0, and from the last example, because there are now 2 different points instead of 1. For the rest of your independent practice, you're going to continue working with mean and mean absolute deviation to measure the variability, center, and spread of data distributions.